Welcome to this short video where I'm going to do a little demonstration of a technique called SQL injection, which is a network security attack often used to try and gain unauthorized access to websites. So hopefully at the end of this short video you'll have a good understanding of what SQL injection is, how it can be used to gain that unauthorized access to websites, and also what web developers can do to protect their sites against SQL. Now obviously the purpose of showing you this in this video is to explain the concept so that you are aware of it for your own application development. The techniques that you see in this video are very unlikely to work in a real live production website because the developers who will have made it will have known about this and will have put into place methods to protect their sites from it. So before we talk about SQL injection, we just need to understand a little bit about how website user authentication works. So you're probably very familiar with this. Most websites ask you to supply either a username or perhaps an email address and a password into something like a login form. And when you put those details in, you might press the sign in button, and that data that you've entered into those boxes is being sent back to a web server that is going to do some processing to see if your password and username match the details it has on record. So in the background, most websites rely on a database to store information such as the user's information, and maybe if it's an online shop, it might have products for sale in the database, or if it's a blog, or if it was Facebook, it might have posts and stories and things like that. But almost all websites, no matter what they do, will have some form of user table, which represents each of the users that have signed up for that service. And so you're going to have in that database a user table with fields such as a username or email address and some form of password, and it's very unlikely to be the literal password, but it's probably something called a hash value, which is a bit like an encrypted form of a password. It's not exactly that, but that's good enough for our purposes today. But basically this data will be stored on the database, and there's probably things like their first name, last name, their address, and other things as well if they happen to be customers of an online store. So here's a very simple example of what that might look like. So this is a table in our database, and as you can see we have these fields: ID, username, password, first name, last name, and we have individual records for the different users in the database. And when we process that login, a user will type in their username, they'll type in their password, and they'll press login. And that data tends to get sent then to a database where it is going to be inserted into an SQL select statement. So the way that the login tends to work is that we have this select statement, select everything from the user table, where the username equals whatever the username is that's been provided, and the password equals whatever the password is that's been provided. And in the case here where it says admin and password 123, those values would go in here. So it'd say admin and password 123. And we can look up in the table that we do indeed have a matching row for where the username is admin and the password is password 123. So this query would run and it will return this single record of results. And our web server will probably look at that and say, great, I've got a result, which means there must be a record where the username and password match, which means that I can trust this person to use the website, so I will log them in. Now, SQL injection exploits this process. It's a form of active attack on a network, and it exploits, which means takes advantage of, how SQL code is processed in order that it might circumvent the need to provide legitimate login credentials. So coming back to this example, it means putting some data in, either in the username or password field, that causes this SQL statement to change in such a way that you don't need to provide a valid combination of username and password. So it relies upon the fact that web developers are going to take the username and password they've been given and pop them into the SQL statement in these places. And it works by, instead of providing a username such as admin, in an SQL injection attack, a hacker might type in a string that results in a syntactically valid SQL expression that always returns some sort of result. And an example of that is closing quotes or 1 = 1 hyphen hyphen. And I'll explain why that works. But if you put that in as a username, if you put it in the username field, that username we can call it a username. It's not really a username, it's a string of characters. But that value would rewrite this SQL statement into one that always returns a result and therefore always causes the website to log that user in. So I'm going to demonstrate this to you. I've got a very simple website here with a simple login form. And this website is powered by a little database, which we can see here in PyCharm. So this is the code that runs the actual web page. And I've got a user table. And if I look in my table, I have 3 users, one called admin, one called test user, one called Joe Blogs, and each one has a password. So if I were to take test user and testing, I should be able to log in. So let's try that. So I've put in the username test user and I put the password testing. So if I press login, that logs me into my very basic website and it welcomes me. If I log out and I try another username password for a user that doesn't exist, and I try logging in, this should fail because there is no Mike Smith user. And indeed that's failed, told me that that's incorrect. So far so good, and it looks like you couldn't hack, even if you knew that there was a user such as admin, but if you didn't know the password, and I try and log in, again it won't let me in. So let's try the SQL attach. I'm going to enter quote to close off the initial username equals quote, and then I'm going to put or 1 equals 1 hyphen hyphen. I can leave the password blank, and I'll press login, and it's logged me in. And notice it's actually logged me in as admin, and yeah, I didn't provide that as the user, and the reason it's done that is that admin is the first result in my table of users. So it will by default log you in as the first user. So how does this work? Well, it works because the SQL injection attack is performed by supplying malicious but, like I say, syntactically valid SQL commands to the database via those user inputs, so the username and password field in a login form being a classic example. These SQL commands that have been maliciously provided are added to the SQL query that is executed by the database engine when it attempts to process the login details. So the database is always going to process this SQL statement. It has to in order to do the logins. So because you know it's going to run this, if we can chuck some extra stuff in here that causes it to do other things while it's running this query, then we can get it to do something else on the database other than just perform a standard user authentication. So here's a bit more detail into that example. So we've got the standard user login SQL query searches for a record where the username and passwords match the values provided. So here's our standard query again. Now if we provide this particular string of closing quote or 1 equals 1 hyphen hyphen, that gets inserted into here. So our SQL query now says select everything from user where username equals blank or 1 equals 1. And then we've got this hyphen hyphen, and hyphen hyphen in SQL or SQL is the prefix for comment. So the database engine just ignores everything after that, so the rest of this doesn't even get run. Now this bit's the interesting bit. Username equals blank or 1 equals 1. Well, 1 equals 1 is always returns to true, or it is a Boolean operator where if one side or the other is true, it will return true. So this basically evaluates to select everything from user where true, which is the equivalent of saying just select everything from user. So what this will actually do is when we run this, it will return all of the records in the user table. And of course, don't forget, our website system is just looking for one match. And if it gets that one match, it logs you in. And if it gets more than one match, it doesn't care. It's got a match, and therefore it will let you in. So we've talked about what an SQL injection attack is. We've talked about how it works, and I've shown you a very simple demonstration of it in process. So the next question is to think about, well, how do we protect ourselves against these attacks? And there are a few methods that web developers can use, and you should know about this from other parts of the course where we look at testing and we look at validation of data and defensive design and building robust programs. So the same techniques apply. So in order to actually protect ourselves, one of the first things and most sensible things to do is use some form of input validation. So you will set up some rules so that usernames and passwords cannot contain characters such as quotes or dashes or multiple dashes in a sequence that could be used in an SQL injection attack. So that just means that users couldn't accidentally set up a username or password that is going to cause some problems. Then also, once input is received from the form, we need to use some input sanitation. And remember, that just means looking through and cleaning up the code that comes in. So they might enter a username and password with this dodgy SQL in it, but as long as we've written some sort of algorithm to receive that user input and check for things like SQL command words or special characters that could look like an SQL attack, if we check for those things and if we either remove them or just send back some sort of error message saying you couldn't log you in, before we actually pass that data to the database to then process a login, then that would be like a barrier that would protect the database. The other thing that developers could do is you can actually set, when the database server is running on a system, you can set user access levels for the database so that different services, such as a web server, cannot perform certain operations on the database that could alter its contents in a dramatic way. Because we've looked at SQL injection so far in a way that allows us just to log in as if without having the correct username and password, but you can also sometimes combine SQL statements in that login box so that as well as logging you in, the next thing it does is it runs some code that might delete all of the data, or it might send a copy of the data to someone else, or it might alter some other information in the form, in a table. And of course, if all this is a login, then there's no way that a login should ever update a customer's email address or find their credit card number. So we can use user access levels to determine, hang on, should the web server be allowed to do this? And if not, then don't allow it permission to do this on the database, even if it's got the right SQL that would theoretically make that operation happen. So there you go. We've talked about what SQL injection is, we've talked about how it can be used to gain unauthorized access to websites, and we've looked briefly at what website developers can do to protect themselves against SQL injection. Now remember, the techniques you've seen in this video are very unlikely to work in a production level website. If you do attempt it, you are hacking and you are committing a crime and breaking the law. You can only do this wherever there's some sort of demonstration available for you where you've got permission to actually attempt it. If you'd like to try it yourself, and you understand a bit about Python and you know how to install additional libraries into Python, then you can download my example website from the link in the description below. You should be able to run that on a Raspberry Pi, for example, quite easily. You'll just need to install the Python library called Flask. So just do a little Google search just to say Raspberry Pi install Flask. That's the only prerequisite. Once you've got that in, you should be able to run the demonstration code no trouble.